I saw his work on conditional GANs for image editing, and I really wanted to reach out and learn more. And so I'd love to hear kind of in your own words, what does that mean to you, and kind of what have you been working on?
Well, it means it all started as a master thesis. So for me, it especially means to know more about something which I'm passionate about, because I just finished my master, and when I started, I knew I wanted to know more about deep learning. But one field that I didn't know much about deep learning, one subfield about deep learning, was generative modeling. So how a neural network was not only able to classify something, for example, if an image contains a dog or a cat, but how it could be able to generate a whole new image. So that was my target, to learn about how this could work. And so this is all this work means this kind of thing. How could from knowing nothing about this, how could I have been able to, well, me and all my team, how we have been able to understand how it works and successfully managed to accomplish our goal, who was to be able to modify this kind of faces.
And so kind of what was so you mentioned talking about wanting to explore like this kind of other kind of problem, and then you kind of led into this. Like, what was the part that said, okay, like I'm going to work on faces, and kind of what goes around that?
The first thing, it was like, okay, what type of application could we do with generating images? And one of my teachers told me, okay, you could, for example, if I take a photo of your face, how will your face look after 20 years? So it was like going through these lines. And so one of my advisor, Joe's, which has been deeply involved in my master thesis and the article that came next, showed me the paper about GANs, and showed me not only this paper, but one state-of-the-art paper which had amazing results and had very realistic images. And then I knew that I had to do something with that. And in fact, well, you have two ways. If you want to generate realistic images, now you have two ways to do that. The first one is GANs, and the other one is variational autoencoders. And so we looked at these two, and we saw that variational autoencoders, although they have pretty amazing results, you are minimizing a reconstruction loss, and as a result, you obtain blurry images. But GANs, the idea behind GAN is pretty simple but effective. But as a result, what you obtain is very sharp and detailed images. So we looked at these two, and finally we decided to go into GANs. And so the first was the problem, how we can modify a face, and then we decided that we could do that with GANs. So it was more or less like that.
Yeah. So I'm going to do a quick screen share, because I have your paper pulled up, and so I think it might be interesting for people to kind of see what it is that we're talking about here. But are you able to see my screen?
Yeah.
Yeah, and so take me through a little bit. Like, obviously, so you're passing in some of these original images, and then it's fascinating to me about how you kind of go through each one of these of reconstruction and bald bangs, and actually how accurate it is. Like what are we looking at when we actually look at something like this?
Well, the cool thing about deep learning is that you have a neural network that sort of learns this by itself. So in the case of GANs, you have two networks, and one network is trying to fool the other. So you have a generator and a discriminator, and the generator tries to be to output realistic images to fool the discriminator, and the discriminator is trained not to be fooled by the generator. So as a result, they compete against each other, and they both get better and better. And what the generator learns is the general idea of how a face looks. So for example, if you saw the process of how the generator is improving and improving, at first the images look very noisy, and then you can see that you can start to see some structure. You can start to see the skin tone, and then the eyes, and then as the iteration goes on, you see more detailed images. So I would say that deep learning, as it's a black box, you could say that it learns by itself how to model these kind of things. Because before that, you needed to handcraft the features. So you were like, okay, if I'm dealing with faces, I will apply a hard detector and describe it with this kind of features. And so the advantage about deep learning is that you don't need to do that. The machine learns by itself, which are more or less the optimal filters and detectors that needs to be done in order to be able to manage to create these real faces. I don't know if I have answered your question.
No, I think I hear what you're saying, and it's this idea of almost flipping the problem upside down is at least what I'm hearing, which is saying in the past you might have said, okay, how do I write an algorithm that detects an eye and detects a nose and what's a face, and then I'm looking at all these different images that may have those, and then maybe I'm trying to figure out these kind of rules that define this piece, and so you're as a human you're writing actually this code out to go do X, Y, Z, and then I think what I hear you saying is now we're in this opportunity to kind of flip that problem and just say, hey, here are a whole ton of photos, and these ones have, let's say, black hair or blonde hair or eyeglasses, and they've been labeled, and then the system is trying to kind of build around that. Is that kind of what you're trying to articulate?
Exactly. For example, because in this case, you are not only giving real images for training this, you're also providing the network with labels. So in this case, for example, when you activate the bit that indicates that the image has blonde hair, the generator is forced to learn that blonde hair indeed looks blonde, because if not, the discriminator would detect that and then would very easily distinguish between fake images. So in this case, the generator is forced to learn that blonde hair looks blonde in order to fool the discriminator, because it is optimized specifically to fool the discriminator. And so it can sound like black magic, but the absolute thing is that it works.
And that's the idea of the adversarial network part of it, right? So it's saying the one is fighting the other, saying like, hey, how do I identify blonde? And then the other one's trying to catch that, and then those two things are kind of going back and forth. And then you as the developer kind of are sitting with the output, which is hopefully super optimized, right? Because the two things were fighting.
Exactly.
Cool.
Yeah.
And then how, like the labeling part of that. So did you guys do that manually, or is that part of what you're talking about of the system kind of learning what blonde is, or like how much labeled information goes in on that initial data set?
The data set, well, first, it is not our data set. It's a public data set, Celebrity A data set.
Okay.
And I'm very glad that this data set was available, because if not, maybe we couldn't have achieved these cool results. And the data set was, I think, 200,000 labels. No, it had 200,000 samples and each sample was labeled. And so there's a lot of data to train optimally a deep learning algorithm, because often the problem about deep learning is that you need a lot of data. That's the reason that maybe 20 years ago, despite these models were already proposed, nobody used them. But now that we're able to use all this data, we can see that it starts to be useful. Because in generative models, you have seen the images. Maybe they look quite amazing, but there's still a long way to go. In fact, these images are only 32 by 32, yeah, and it's pretty small. And so there's still work to do on generative models.
Cool. And what are some applications that you kind of foresee this type of work being applied to?
In our very specific case, for example, if you would like, you could use, for example, instead of Snapchat, for example, if you're familiar with the Snapchat, it detects the key points, it detects your eyes, your mouth, and then it just applies a filter to your face. But here, if you use that model, this model learns and understands how your face looks, and it applies subtle changes that it preserves still your identity, but then you can see that indeed, for example, I like to, in this example, I like the gender change column, which is the third on the left, on the right, sorry. And you can still that, you could see that the person is more or less the same, but you can see very subtle changes that if it was a man, the man looks more womanish or vice versa. So for example, for a Snapchat, you could use that, which would be a cool feature. But for example, you could also use that instead of the typical sketch that is done for detecting criminals, to finding criminals. You could use that, this application, which is more realistic and also it's more interactively. And this is on faces, but you could apply this model on any other kind of thing. For example, let's imagine that you want to change your bedroom. You could train a model with bedrooms and labels about these bedrooms. You could take a photo about your bedrooms, and then you can decide, okay, how would an additional windows look here? Or what about if I add a closet here? And
Right.
then this model could very organically change your bedroom with these modifications. And then you wouldn't require of a designer to manually change that. This could be performed completely autonomously.
Yeah, that's really interesting. So are you what so I'm thinking, okay, so the bedroom one is a really great example, and I think I see the application, and I think like the police face one is a great one too, right? It's that's immediate kind of, and I actually even think of, you could probably give a wide description or maybe a wide range of what those faces. So I think of the police, right, and they get 5 eyewitnesses, and they might get 5 different descriptions. It'd be interesting to kind of aggregate, and then also kind of lean towards each of the individual descriptions to maybe give a range, which would be fascinating. The bedroom part of that, so I think that's fascinating around kind of interior design or maybe even architecture, it seems like could be implied. But what kind of data set would you imagine would be required to do that? So like I kind of get it conceptually, but what kind of data set would you need to train the algorithm on, or the model on, in order for it to understand that?
Do you mean the size of the data set?
You know, size I think is part of the implication of my question, but I'm kind of suggesting, like, do you need a similar data set of like 200,000 highly labeled kind of data or images that kind of set that foundation?
Well, I have to admit that GANs for now they have problems with the structure. So our model, which is trained on face dataset, it looks more or less correctly because all the faces were centered and cropped. So all the eyes are at the same pixel locations. If you were to change that, that is, if you admit translation, rotations, and all these things, then the quality of the samples would considerably decrease. And so when it's about, for example, I think the bedrooms wouldn't be a problem. But if you want to model animals or these kind of things, on the NIPS, it was shown state of the art results, and it seems that now it's promising that maybe now it's starting to model correctly these kind of things. But I think that for the simple the data set, that is, if it has less variation, for example, in the case of faces, if you have all the faces centered, there's less variation. So the less the variation, the more easily the more easily to model these kind of things. Mm-hmm. And also, if you can provide label, it has improved that if you provide labels, the quality of the samples also considerably increase. But if you want to model maybe buildings, and for example, churches sometimes has strange forms and structures. So maybe then you could also, the GAN could have problems to model that. Mm-hmm. So the more robust the structure, the better.
Yeah, it's interesting. Like a face, really, in general, is a relatively, for most people, it's a relatively set range of, I guess, our standard deviation of where our eyes and how far they're set apart, and our nose and our mouth all relatively in the same range. And so while it's interesting because as a human, I think we can see a human face difference, very, very small differences very clearly, right? And you talk about seeing faces and everything and all these things. And so it's a really interesting data set because it's very different yet very similar, but enough for a human to look at that and go, oh yeah, that looks female over male, or that looks, glasses, like that's I think I see where you're getting at.
And in fact, if you are, for example, in the case of, I saw models of cows and monkeys, and it was trained on ImageNet, which has monkeys and cows on every type of perspective. And so if you add all these kind of if you don't have constraints over how the data set looks, then you will get very weird results. Mm-hmm. So GANs were proposed only 2 years ago. So I think that we still have a long way to go to how to improve them. But I think that at the end of the day, we will manage to model complex things.
Do you foresee, like, is there like an application, I don't know the exact word here, of saying you could actually, I'm trying to think of the best way to ask this question, but
sure,
taking like, for lack of a better word, like a messy data set and running it through some sort of algorithm or models to try to tidy it up. So let's just say, for example, that there were a lot of faces that you had, but they all had a slight, like, kind of left to right range. Could you hypothetically work on a model that is then bringing them more Titan-centered so that this particular model will work, or would you take the current model that you have and try to expand it to adapt to that range and face? Does that make sense?
So an algorithm to clean a data set? This is
Well,
what you mean?
I guess, yeah. I never thought about it as clean, but I think that in this context, when you're working with an image, yeah, that would be kind of, I think, what I'm asking.
Well, what I've seen that people do with GANs, which is not directly that, is that if you have a data set, because GANs are unsupervised, this means that you can train over a data set without any kind of labeling. So one thing that you can do is train, let's say that you have a data set which isn't, it hasn't any kind of labels, but you could afford to, I don't know, maybe label 200 samples, which is affordable. Then you can train, let's say that your originally unlabeled dataset, it's about 1 million samples. So you can train a GAN over that. And then the discriminator learns the future of how to model this dataset. And then you can take these futures and put it on a supervised neural network where you have these 200 labels. And then it has been proved that using the futures of the discriminator over these 200 labels, it's better than just training the model with these 200 labels from scratch. So more or less, it has this kind of advantage. But the exact thing that you mentioned over cleaning a data set, I don't think for now it is possible, to my knowledge at least.
Let me take a moment to say that this wouldn't be possible without companies like Amazon.com. If you have experience with machine learning and are looking for a new challenge, they have over 100 opportunities available. Be sure to check out the link in the description, and let's get back to the show. I've talked to a couple other people, and we've talked about kind of how data in big data, there's just a lot of it. And you mentioned it, and how this enabled a lot of the actual kind of math or the models that you're working on to actually work, because we've been able to capture these data sets. And it seems that there's this interesting juxtaposition between there are these big data sets out there that have these really interesting applications, and then I find myself, while talking to people in this space and kind of exploring other opportunities, that there's also this need of like, okay, like I would love to have a data set that did XYZ, and going to capture it is an entirely new challenge. And I heard Google Home, if you're familiar with it, there was some conversation about what Google Home's actual intention is, and is it just training data for the Google Assistant idea? And Google in 2007 had done a 411 Assistant, and for them, it was just about capturing voice data so that they could then train another model to go do another thing. And I feel like that's a little bit of this situation, a lot of great data sets, but as I think about, oh, could we do XYZ? It's like, okay, well, now I got to go find that data set, and it's a new problem to go solve.
That's the one big constraint, because for deep learning, the first question you have to ask when you are going to model a deep learning algorithm is there enough data? And so, of course, if you are not, if you don't have the resources, or you're not Google or Facebook, maybe you will have a very hard time labeling all this data. Well, not only labeling, but obtaining raw data, it's even difficult. So yeah, this is a very well, now thanks to the smartphones, every one of us are generating a lot of data. But if you're not Google or if you're not Apple, you are not obtaining this type of data. Fortunately, Google and Facebook and some other companies, they release sometimes some data set with which we can work on. But yeah, of course, if you want to, I don't know, create a pen data set to model different types of pens, and there isn't any, you will have to put money on that. Yeah.
Right. Yeah. That's interesting. Yeah, that's a interesting dichotomy, and it really gives you a sense of how much power they really have as these tools get used more and more. And I think of Google and how much data I give them, right, between Gmail,
Yeah, exactly.
Google Maps, and Google Docs, and
maybe in this very conversation we're providing a lot of data.
Yeah, exactly, right. All the Hangout data. Yeah, it's.
Well, and the second question that you have to ask is, do you have the resources, the computer resources because this model that I trained, it was trained on my desktop computer for 4 or 8 hours. But if you want to train, I think I heard that the Google Translator neural network, it was trained over, I don't know how many computers, but maybe for about a week. So wow. You also need very strong resources.
Mm-hmm. Yeah, that's another interesting point, and you see the GPU chips starting to get a lot more love, and some exactly. of the interesting hardware advances that they're doing. It does seem to be a little bit in a boom type, gold rush type phase right now, where you're seeing, I think, a lot of software applications as well as a lot of hardware applications that seem to be working together, which is, I think, part of the reason we're seeing a lot of progress in this space, which is exciting to see. So,
In fact, 5 years ago, it was crazy to run a neural network on a GPU. But now, if you don't run in a GPU, you will be like 10 years just to make one iteration.
Yeah, you mentioned running it on your own computer. What's your setup?
I have an NVIDIA GTX 780 from 2 years ago, and an Intel 7, and I had eight gigas of RAM, but for this master thesis I needed to upgrade to 16.
Okay, cool. No, that's awesome. I should be asking that question more often. I realize it's a fascinating one to know kind of what hardware you guys are running when you're doing this research.
Yeah.
So what are you up to next? Like, what's the next? Are you researching something? Are you kind of, what's up?
Well, I finished my master thesis, and what I've been doing now, I finished my master thesis, and my advisor proposed me to extend my master thesis in order to publish on NIPS. I presented this paper 3 days ago in the NIPS, and now that I'm done with that, I like research, but 2 months ago, I had to decide if I was going to pursue a PhD. And I finally decided that I was not going to do that, because PhD is very focused on publishing and writing, which is something very valuable and needs to be done. But I feel more motivated on being in touch with real world problems, maybe applying research, all the knowledge I know. So instead of being conditioning over obtaining a 3% more on a given article, or maybe because this is very cool, but as for now, if you want to create a product, this is very easy to do. But if you want to create a product, you also need a lot of knowledge. So now I'm interested on this part, to how can research can be transferred into society to help people. So as for now, now that the NIPS conference is gone, I will be seeking opportunities within research engineering. Cool. So if every listener is interested, please contact me.
Yeah, that was going to be my next question, is how can someone be helpful? And so that sounds like that can be helpful if you're looking for a sharp guy to work on some cool problems.
Well, if someone wants to be helping on this, because GANs are, we have just started to scratch the surface of GANs. So if anyone wants to be helpful, I will encourage them to get hands-on GANs. It's a very, as it has only 2 years, there are not many papers, and it's easy to follow more or less the state of the art. So I would encourage to go on that, because GANs are focused on unsupervised learning, and solving unsupervised learning is one of the main things of AI. Yeah. So I would encourage anyone to go on GANs.
And with that note, I will put your GitHub project in here. It is really well written up, and you've shared a ton on it. So I appreciate. I think the community appreciates anytime that you're that transparent. So, but I will put a link to the actual GitHub project.
I made a GitHub because, in fact, my whole work is based on the work of Soumith, the dCGAN Torch project. So without this, it has been very valuable for me, because without this, I could have spent all my master thesis only programming GANs. So I encourage anyone to make all other projects open source, because it's very valuable and it's very helpful.
Yeah, no, it's great. And I think, there's the open AI movement, and there's a lot of, there's a lot of conversation around artificial intelligence in general, and how to make it as impactful for humanity and all of humanity as possible. And I think open source is a big part of that. So, thank you for that. Okay, so the one last thing that I like to do is kind of like a 30-second, 60-second soapbox. Anything you want to say to the world that might be listening?
Yeah. The other day, I heard Andrew Ng saying that artificial intelligence was the new electricity, and I think I agree 100% with that. I think that AI will be the next big thing. So I would encourage anyone listening to go and join the AI community and be part of that change, because I think it's a very important thing that will happen. Maybe sure that in in a shorter time that we expect. So I think that it's a very valuable thing to do, and anyone should be encouraged to join this community.
Yeah, I saw that electricity piece too, and I think he might have written a little mini blog post or something about it as well, or otherwise someone from Andreessen Horowitz did. But it is a really interesting concept, and one of the things that they commented on there was that there, back in the day, I think that there was like head of electricity or something like that, of like these roles that were thinking about how a business might apply electricity to their exact business model, and how in this day and age we would think like, what do you mean apply electricity to your business? Like, and I think you're right. And Google's, they are talking about being AI first, and they used to be mobile first, and now they're AI first. And so I 100% agree with that. But cool.
I think it will improve our lives, and I think it's definitely worth trying to get into this.
Yeah, cool. All right. Well, I really appreciate you taking the time to kind of sit down and take me through some of this. Like I said, I'll put some links in the description. And I appreciate
your opportunity to talk about my research.
Yeah, I think that the audience here too is technical proficient engineers, and I think I spent a lot of time talking with my team at a startup, and they're a bunch of engineers, and they find this stuff really fascinating. And I think that it's been this interesting like level of, you see a thing on BuzzFeed, or you maybe see your actual work in this full document, and I think it's really difficult sometimes to consume, to sit down and say, all right, I'm going to get knee deep in this math. And so that's one thing I'm trying to do, is kind of bridge that and say, hey,
I think it's a very interesting idea, this podcast.
Cool. All right. Well, appreciate it. I'm going to stop the broadcast. Thanks for joining.
Okay. See you.